Okay. Okay.
Perfect.
Okay. Thank you for the introduction. I'd like to talk about our work. We focus on friendship trade-off of numbers and closeness. Our time and cognitive resources for social relationships are limited. We cannot have many close friends due to these limitations. So we would balance the distributions of friendships. This allows a trade-off between contact frequencies, that is closeness, and the number of social relationships. This trade-off is described as inverse relationships, like this. Here, Q is mean contact frequencies of all social relationships. K is the number of social relationships. The strength of the trade-off depends on communication tools. Elaborate communication tools such as face-to-face communication and primates grooming, social grooming, show big trade-off. And on the other hand, lightweight communication tools such as Twitter and emails show strong trade-off. For example, Twitter is easy to have many acquaintances, but it is difficult to keep many close friends. In contrast, face-to-face communication is too easy to keep close friends. On the other hand, it is sorry. Okay. It is difficult to make many acquaintances by face-to-face communication. We can observe this trade-off changes by this coefficient A based on fitting this model to communication datasets. When A is larger than 1, trade-off is strong, like Twitter. A is smaller than 1, trade-off is weak, like face-to-face communication. We aim to construct a simple model to explain this trade-off. Here, we think a communication model where agent activations only depend on messaging from others. In this model, there are two activation patterns. First is activation cascade, like this, and that is node level activation. Second is mutual activation, and that is edge activation, like reply. As a result of agent-based simulations, we found 5 patterns based on trade-off parameter A. We draw this phase diagram by node and edge activation strengths. This area shows that our model showed empirical social relationship features such as the trade-off. In this area, trade-off parameter A changed from A smaller than 1 to A larger than 1, depending on strength of node activation and the strong edge activation. This suggests the phenomenon of the trade-off of social relationships requires node and edge activation. One-side activation does not explain this phenomenon. Additionally, the balance of both changes changes the trade-off between closeness and number of friendships. Elaborate communication like face-to-face communication may have weaker node activation than lightweight communication like Twitter. In summary, our simple model shows the trade-off between the number of social links and the closeness and its change. This feature of social relationships depends on node activation and strong edge activation. That's all. Thank you for your kind attention.
Thank you so much.
Thank you.
All right, next up, we have a presentation by Susana Ramirez